All right, so we're going to get started with our lesson. The word or the term inverse operations, super important in algebra. And I love this lesson because it's introducing it, not in the way you're going to use it for equations and inequalities, but at least to get the idea of what is an inverse operation. So 1-8, solving equations. And I should clarify that. We're going to use it for solving equations, but I'm going to use the word primitive in a primitive way. That means in a way that is not the way you're going to do it for the rest of the year, but you're going to start getting the idea, oh, that's an inverse operation, and that's an inverse operation, and then you'll be ready for the more technical way. So solving equations using, and the key phrase is inverse operations. That's the key. All right, so does anyone know what an inverse operation is? Have you guys ever heard of that, Mackenzie?
An inverse operation is kind of like the PEMDAS method, except it's backwards.
Okay, so I think if you get into solving equations, technically you're going to be doing PEMDAS backwards in a sense. So, okay, I see what you're thinking. But what's just inverse operations, not relating to PEMDAS necessarily? But actually, Mackenzie, now that I think of it, good thinking. Order of operations, inverse operations, they're kind of, there's a relationship there. But does anyone know what the inverse operations are? No? Do you know what they are?
An operation that you could do to undo.
There you go.
Addition, you subtract, so the opposite of addition is subtraction.
Okay, go ahead and write this down. The first pair of inverse operations are addition and subtraction. Addition and subtraction. So we'll talk about that first. And yeah, your book says it very well, John. Thank you for reading that for us. I should put these undo each other. So addition and subtraction undo each other. And that word undo is like, what are you talking about? Well, let's get an addition fact. Very simple, single digits. Just this plus this equals that. Yes, ma'am? Any problem?
2 times 4 plus...
addition fact.
2 plus 3.
Okay. 2 plus 3 equals 5. You guys in agreement with that? That's an addition fact. Okay? Now, I can come up with 2 subtraction facts with these numbers. What's one subtraction fact that I would come up with here? Tristan. 5 minus 3 equals 2. That's a fact. It's using those numbers. And I need a second subtraction fact. 5 minus 2 equals 3. Okay? All right. So let me see if we can figure this out. Let's look at this first problem. Actually, you guys did really well picking good ones. 2 plus 3 equals 5, right? 2 is my first number. That's my original number. If I add 3, I get 5. What happens when I subtract 3 from 5? I get 2. Let me see if I can give you a problem that relates these 2 facts together. I start off with the number 2. If I add 3 and then take away 3, what am I left with? The addition of 3 and the subtraction of 3 undid each other. Or they undo each other. Does that make sense? Because they're inverse operations. Addition and subtraction are special because they are linked together. And I'm going to show you, and this is where it gets cool. In algebra, instead of saying addition and subtraction as separate operations, I'm going to talk about it like addition only. So imagine this. Look at this problem right here. Is that addition or subtraction? Subtraction. It's subtraction and addition. What? Yeah, we'll talk about that later. Does anyone see it, though? Do you see the addition? Yeah. Can you show it?
2 plus 3 equals 5.
Okay, you can see like the inverse operation, but how can you see this right here as an addition problem? Ready? It's 5 plus negative 3 equals 2. Okay, that's deep. That's deep. That's for later. All right, let me give you another addition problem. This is one that the book gives, and it's nice because when we deal with these inverse operations, a lot of times we want to deal with just numbers, but you can deal with variables as well. All right, so here we have 9 plus n equals, I'm going to change it up, 9 plus n equals 17. All right, that's an addition fact, right? Do I know what n is immediately, like when I first see it? No, but I can figure it out pretty quickly because I use inverse operations. So give me 2 subtraction facts that I can come up with from this addition fact, one of them. 17 minus n equals 9. Do you guys agree with that? Okay. The other one?
17 minus 9 equals 8.
17 minus 9 equals n. Okay. Those are both subtraction facts that come from this one addition fact. Do you guys kind of see that? Okay. Now, let me ask you this question. Are these both as useful? Do they have the same usefulness? What do you think? The same usefulness. I hear yes.
I say yes.
I say yes, I hear. Okay. Which one's going to help me to find n? The first or the second subtraction fact? The second one. Why? Because
It's more efficient.
you just use the numbers. 17 minus 9 is what? 8. So you get what n equals is 8. This one right here, could you use it? Yes. It's just not as effective. That means, okay, now I have to change it, and then I have to think of it this way, but it's kind of like a 2-step at least. So the second one is more useful. Some facts are more useful than others when you have a variable. Let's see. Let me do a little review. Is this an equation, Timothy?
Yes,
Why?
because it has an equal sign.
Oh, cool. It's an equation. Equal sign, boom, equation. Is this open or closed? Josie.
It's open.
Open, really? Why?
Because of the variable.
Oh, yeah, it has a variable there. Oh, gotcha. This one right here, Michael, open or closed? What? Wait, you're telling me both of these are open? Are you guys telling me that all 3 are open? Because it has what? Variable. Boom, it's open. So you can solve it. Which one is the easiest one to solve? The first, second, or third? What do you think? Third? Any others for 3? The third one? Okay. Yes, I can see this and think in my head like that, but this one's just straightforward 17 minus 9. Okay. Let's move on to multiplication. Does anyone know what multiplication's inverse operation is? Division. Multiplication. And division. So these are the 4 basic operations. And they're cool because addition, subtraction, they can undo one another. They're inverse operations. And multiplication and division are also inverse operations. So they can undo one another. Give me a number. Just give me a number. Simple, nothing too difficult. Yes, ma'am? 6. Okay? 6 is our original number. Okay, give me another number. Nothing too big. Yes?
1.
Okay.
2.
2. Let's go to 2. Good.
4.
All right, you start with 6. How about this? 6. When you multiply that by 2, what do you get?
12.
12. When you divide that by 2,
You get 6.
you get your original number 6. The multiplication of 2 and the division by 2 did what? Undid, or they undo one another. Good. That's it. All right, so let's get another example here. 3 times 5 equals 15. Wait, is that true? Yes, it's automatic. I got to know it. 3 times 5 is 15. Give me 2 division facts from this one multiplication fact. Excuse me. Yes, Caroline?
15 divided by 5
Divided by 5 equals 3. Good. Give me another one. Tristan?
15 divided by 3 equals 5.
All right, are you able to pull out both of those division facts from that one multiplication fact? I hope so. Okay? And you got to check to make sure they're true, because sometimes you can come up with a fact, and then you're like, wait, that's not true. So check it. Maybe you wrote something wrong. All right. When you multiply 3 by 5, you get 15. And then when you divide by 5, you get 3. You undid those operations. Okay. I think that's pretty clear. Let's do it with a variable. 12t. Wait. 12t. Let's go with equals 48. What operation is going on there? What is that? Is that addition? I'm confused here. Brady? Multiplication right here, right? But there's no multiplication symbol. Explain this to me. I'm confused. How'd you say multiplication? I don't see it. There's something I don't see. John?
A variable next to a number means multiplication.
Good. A number in front of a variable with no symbol in between is multiplication. In fact, guys, take a note. Swivl. You have to write your expressions with multiplication of numbers and variables like this. Should you write it t12? No. If you're going to write it that way, put t times 12. But this is the proper way of writing it. All right, 2 division facts. I need help. 2 division facts, real quick. Marissa?
48 divided by t equals 12.
48 divided by 12 equals
And 48 divided by 12 equals t.
t. Which one's the most useful, first or second? Second one. What's 48 divided by 12? Boom. What is it?
4.
Yes, 4. 4. T equals 4. That's okay. How many of you struggle with your 12s? 12 facts. Times 12? 12's timetable? Okay. Get it. Start practicing it. 12 times 1, everyone.
12.
12 times 2.
24.
12 times 3.
36.
12 times 4.
48.
12 times 5.
60.
Okay, I heard many things, but 60. 12 times 5 is 60. 12 times 8.
72.
12 times 8.
96.
96. 12 times 10. 120. I lost my track because of the roasted comment. 12 times 9.
I don't know.
108.
108. 12 times 9, everyone. 12 times 9, everyone. 12 times 9. 12 times 9. 108. So the more times I repeat it, the more times it gets into here. 12 times 9. 9 times 12. 12 times 9. 12 times 10. 12 times 9.
108.
Okay. I hope by tomorrow, if someone threw out 12 times 9, your answer will be 108. You just know it now. And it's just memorization. Like, how many of you know your phone number? Okay, yeah. I remember when I was younger, not your age, younger than that. I just didn't know my number. Hey, can you call your parents? I don't know. What are you supposed to do? Then you memorize it, and it says how many digits? 7, 10-digit number. So you memorize a 10-digit number in order, and a lot of you it's 864 to start with. But you memorize it because you just repeated it. And now no one's going to say, do you know your phone number? You mean to call? Yeah, you know what your phone number is by now. Do you know your address?
Yeah.
Okay, some of you, if you don't know your address, it'd be good to know it. I'm not saying you have to, but it's good. But same thing, memorization. You just memorize it. Do you know what the score was of last night's games?
Yes.
Some of you do. Do you know the scores of Saturday's games?
What game?
Games. Yeah, depending on who you cheered for, yeah.
Monday?
Broncos?
Yes.
Oh my. I thought I left Denver and left the Broncos, but did they win or lose?
I wasn't awake.
Oh, well, gotcha.
I hope that.
Okay, let's look at example 1. What we're going to do, guys, is we're going to come back after the break. Oh, wow, time out. Yes. We're going to just stay here for a few more minutes, and then I'll let you go. Example 1. Go ahead and let's start that up. So I got off on a tangent with memorizing. And yeah, really, multiplication facts, if you memorize it, it's going to help you out. All right, so A. Michael, can you read A, the problem? on page 42.
Okay, so B minus 6 equals 42.
B minus 6 equals 42. All right, what did the instructions say to do for A, B, C, and D? Tristan?
Solve each equation by using the inverse operation.
Okay, what you need to do on your homework that asks you solve these equations using the inverse operation is you have to write an equation that's the inverse of this one. So what is the most useful inverse operation you can use on this one? John?
6 plus 42 equals B.
Yeah, you can say 6 plus 42 equals B. So what I do is this. Are these two related facts? So do they have the same numbers? And are they both true? And the answer is yes. And then you could do this mentally, or you could work it out. What's our answer for B? B equals 48. B equals 48 because you're solving the equation. All right. You're not sure of this answer. You're like, I really hope this is it. It's not an odd number. So what do I do? What's 48 minus 6?
42.
What did I do there when I said 48 minus 6 equals 42? What did I do? What's that process called? I did it. I checked it. So this is the inverse operation. This is what I think the answer is. And then what do I do? Check it. And if you need to put a little check mark, that's fine. All right, B. Jensen, can you read B for me?
C plus 16 equals 54.
Good. All right, so here's my initial fact. I need to use the inverse operation. So give me an equation using the inverse operation of addition that will be very useful. Am I Grace? 54 minus 16 equals C. Okay, that's what I do. I just write that down. Whatever fact you're going to use, you write it down. And then if you could do this in your head or if you need to work it out, what's 54 minus 16?
38.
And you can write it, the number equals the variable or the variable equals the number. Both of those are okay. 38 equals C. Mr. A, how do you know if that's your answer or not?
Check.
38 plus 16 is?
54.
So that has been checked. And you can do that mentally, or if you need to write it down, 38 plus 16, figure out what that is. It should give you 54. All right, C, Bella, can you read for me C?
Yeah. B divided by 9 equals 16.
B divided by 9 equals 16. All right, I need an equation with the inverse operation. So what's going on here so far? This is what operation? Division. So I need a multiplication fact. Go ahead. 16 times 9 equals V. Mr. A, could I have said 9 times 16 equals V?
Yes.
Really? That's different, isn't it?
No.
It's not? What property says that's not different? Commutative property. All right. What's 16 times 9? Distributive property. 90 plus 54. 144. 144 equals V. Mr. A, is 144 divided by 9 16?
Yes.
Yes. We checked it. All right. Look at D real quick. Someone read for me D, and then I'll explain what they're doing in that bold type. This is a great note that I want to bring up. All right, Marissa, read D, the problem. 37.5. Let me make sure I wrote it the way they did. Okay, they wrote it the proper way, which is good. So 2.5s equals 37.5. Okay, what's the related division fact that will help me to solve this right here? John?
37.5.
Yeah, and I'm going to write it like this. You could have written it with the division sign, but that equals S. Okay. Look what they say in the bold print. So it says write a related division sentence, which we did. And then what do they say under that? Nice! Use a calculator. Okay. The calculator you will use is special. Yeah, it's not, well, some may say it's battery powered. Some may say it's solar powered. I say it's powered by pizza or chicken or pasta, whatever you're eating today, and sleep, which is very nice. Listen to me, guys. Those calculators that we use like later on, they're good for us. They're good tools. If you use them well, and take advantage of that. But what I want you to do is, until further notice, you will use the calculator that the Lord has given you. Some of them are version 1.7. Some of them are version 2.3. Your versions may be different from each other, which is fine, but all of us should be able to work this problem out, some more easily than others, but it's a good practice problem. So if they ever say use a calculator, you need to ask, Mr. A, can we use an outside calculator? And I'll say yes or no. My answer is normally going to be
Yes.
no. Good answer, though. 50-50 chance. Okay, how do I do this problem, though? I don't know. Which number goes in the box, which number goes outside the box, and it's always, always, always this way. I want to know which one goes in the box, so we know it's going to be a problem like this, and which one goes outside the box. And outside means the divisor, not the quotient, because they didn't make it that easy for me. Okay, Emma Grace.
37.5 goes inside,
Really?
and 2.5 goes outside.
Okay. Is that important to know? Okay, by the way, on your quizzes, when I grade them, we had some division, and some of you did this. Flip. And then the problem got really hard, because now you're dividing a number, and it's a quotient of a repeating or non-ending decimal. Isn't that kind of hard? Okay. Normally, the case is you flip the numbers. But Mr. A, what determines whether this number goes in the box or outside the box? How do you know that? How do you know that? There's got to be a way to know, because I thought it's is it the bigger number goes in the box? Okay, what do you think, John?
Well, in like fractions, the numerator, which is the top number, goes inside.
Okay, ready, John? I want you to rephrase that. You're right. I want you to say the numerator always goes in the box. Go ahead.
The numerator always goes in the box.
Numerator always goes in the box. What if this is a small number? It always goes in the box. Do you understand me here? Please follow that. Like if there's ever a doubt, like the numbers are bigger on the bottom or top, whatever, and you're like, are you sure, Mr. A? I am positively sure. The number in the numerator goes in the box. Dividend over divisor, always. Always. Swivl, did you get that? Always. Okay, but I can't do this division problem like it is, so what do I do? What can help me out? Well, you guys know anything about the little decimal point? Yes, ma'am.
You have to move the decimal over one place to the first number and the same amount to the outside.
So really I'm doing 25 into 375. And I'll put my decimal point at the end just so I know it went somewhere. You want to get this outside number to be a whole number, okay? That's your goal. If that's a whole number, great. If it's not, that's okay. This number must be whole. 25 goes into 37 one time. That's 25, remainder of 12. Bring down that 5. 25 goes into 125. Any remainder?
No.
So what's my answer for S? S equals 15. Okay? Did you really need a calculator to do that? Of course you did. It's this one you needed. Okay. And it can even write on things. These are advanced calculators. They can even write in cursive, which is amazing. Nice. All right. Example number 2. I'm just going to go over this real briefly. Example 2. The sum of 215 and a certain number is equal to 266. Find the number. The whole point of that problem is saying this. When you're solving for a problem, sometimes you're looking for a number, okay? You're looking for this missing number. What you can do is this. This is cool. Instead of saying a certain number, why don't you use a variable, right? Because this isn't a certain number, an unknown number. And what's an unknown number also known as in math? A variable. Good. So you can use any letter to cover that up. If you pick a good variable, it should match up the idea of what you're looking for. So in example 2, the sum of 215 and a certain number is equal to 266. What do you want to define your variable as? What letter do you want to make it? What do you think?
X.
X. That's a good one. What's another choice? Z. Y. J. Some letters to avoid would be what? What do you think?
1.
T, if you can, try to avoid it. Any others?
L.
X.
L. X is a good one because that's a normal one, but yeah, I can see how it can be confused with multiplication. What about S? Think that's a good one? Why might S be a little bit iffy on picking it out? Because S, I mean, what's wrong with S? Maybe you say, my last name starts with S, Mr. A. Yep.
It might look like a 2.
It could look like a 2 or a 5. Yeah, see how S can go either way? Wow. All right, so try and pick good variables. All right, your homework. On page 44 and 45, you're going to be doing 17 to 36. 17 to 36. I'll write this in just a moment. 17 to 36, and then you'll also do, speaking of football, 45 through 48. 45 to 48. So I'll go ahead and write that down. I'm going to end the recording.